Hi everyone, welcome back to Math Tutoring. Today's lesson is on algebra, solving systems of equations involving three linear equations. So let's start off with an example. Now say you're asked to solve the following. So you're asked to solve the following. So you've got three unknowns and three equations. I should say three variables and three equations. And they are unknowns because we're going to solve for x, y, and z. So what you're going to do first, so I'm just going to number these 1, 2, and 3. So we're going to start by maybe eliminating the x in equations 1 and 2. So we start by eliminating the x in equations 1 and 2. Okay? So to do that, what we're going to do is take equation 1 and multiply it by 3. When we do that, we get 18x minus 12y minus 21z equals 51. And then number 2, we multiply that one by 2, and when we do that, we get 18x minus 14y minus 32z equals 58. So the reason I did this is because I want to make these two the same. So if I want to eliminate x, I have to get these two to be the same number. So I can do that by multiplying this one by 3 and by multiplying this one by 2. But whatever I do to this part, I have to do to the whole equation, not to change the equation. So I have to do that's the same thing to everything in the equation. And whatever I do to this, I have to do to every other thing in the equation. So if I multiply this by 2, I have to multiply this by 2, this by 2, this by 2. If I multiply this by 3, I have to multiply this by 3, this by 3, and this by 3. Okay? So what I do is I multiply equation 1, the whole equation, even though I'm only trying to change these two. That's what my goal is, but the other ones will change in the process. So I multiply everything by 3 here, and over here I multiply everything by 2. When I do that, I can subtract. So 18x minus 18x is 0x. So we just eliminate the x. And then over here we have negative 12y minus negative 14, which becomes negative 12y plus 14y. So that becomes 2y. Negative 21z plus 32z becomes 11z. And then negative 51 minus 58 is negative 7. Okay, so now we got an equation with only y and z. Now, we do the same thing for equations 1 and 3. So what we're going to do now is now the second step is, so we want to now eliminate x in equations 1 and 3. So now we eliminate x in equations 1 and 3. So to do that, I take equation 1 and I multiply it by 5. And I take this one and I multiply equation 3 by 3. And the reason I'm doing that is because I'm going to make this 30 and I'm going to make this 30. So I'm going to make them the same thing. And I can do that by making 16 to 30. So I just multiply 60 by 5 to give me 30. And then if I multiply 10x by 3, then I get 30, because both of those numbers would go into 30. So that's the smallest number that I can think of that they would both divide into evenly, okay? So because I do that to the first part, I have to do the whole thing. And this way I'm trying to eliminate the x in equations 1 and 3. So I multiply everything by 5 in equation 1, so I get 30x minus 20y minus 35z equals 85, and then for the last equation I multiply everything by 3, and then I again get 30x minus 15y minus 9z equaling to 69. And now I'm just going to subtract. So when I do, Here I get negative 20 plus 15, so that becomes 35y. Negative 35 plus 9 becomes negative 26z. And then 85 minus 69 is 16. So now I got another equation with only in terms of y and z, and that's my goal, because now I can start solving from these two. I can figure out what y and z are. Okay, so that's what you want to start off by doing. So this one for this one we looked at this, and we thought of, okay, let's multiply this one by 5, and let's multiply this one equation by 3, and if we do that, then the two x's will be the same, and then everything else doesn't matter. We're just trying to eliminate the x's when we subtract. Okay, so we get that part. So now we've got these two equations. Okay, so now what we want to do is we want to see what we can eliminate there. So what I'm going to do is, when I look at these two, I've got 2y plus 11z minus 7, and I've got 35y minus, just 1 second, sorry. I think I did something wrong here. Sorry, that should be a 5y. Okay, 5y minus 26z minus, yeah. Okay, so over here, sorry, so that's negative 20 plus 15, so that becomes only negative 20 plus 15, that should be negative 5. Okay, so that is a negative 5, not 35. So negative 5y minus 26z minus equals to 16. Okay, so now I look at these two and I think of, how can I make these two the same? Well, I can turn them into the two y's. I'm looking at the y's now. So how can I make the two y's the same? Well, I can multiply this one by 5, and I can multiply this one by 2, and then I can just add the equations, and then that would eliminate the y's. So now what I do is I multiply equation 1. Now my new equation 1 is this one here. And my new equation, my new equation 1 is this one, and my new equation 2 is this one. So I take equation 1, my new one, and multiply it by 5. And when I do that, just 1 second. So our new equation 1 is this one right here, and our new equation 2 is this one. So what we're going to do is multiply this one by 5, and that's going to give us 10y plus 55z equals to negative 35. And we're going to take this one, equation 2, and multiply it by 2. And when we do that, we get negative 10y minus 52z equals 32. And in this case, because they're opposites, if you just add them instead of subtract, that will eliminate your y, and you'll end up with 3z equals negative 3. And then you can actually solve for z. So dividing both sides by 3, I get that z equals negative 1. So I just solved for one of my unknowns. Now what I'm going to do is substitute that into any equation with y and z. So if I take this and say substitute it into this one, I would get 2y plus 11 times negative 1 equals negative 7. So then 2y is equal to, or 2y plus, or sorry, minus 11 is equal to negative 7. So 2y would be equal to, bring the 11 over to the other side, it becomes a positive, so 2y equals 4, so that means y equals 2. So I just solved for my y. Okay, and I did that as you notice, I looked at only the equations that have a z and a y, because I have z, I could just, if I plugged into these, I wouldn't have been able to do that. I wouldn't have been able to solve for y because I still have an x in the way. That's why I picked one of these equations, one of my reduced equations, my new equations, and I plugged that z into one of them. Now that I have z and y, I plug those into any of these equations, and I can now solve for x. So I can plug it into, let's say, the first one. So 6x minus 4 times 2 minus 7 times negative 1 equals 17. And then I get 6x minus 8 plus 7 equals 17. 6x minus 1 equals 17. 6x equals 18. And then x equals 3. So now we just solve for x. Okay, and there's more than one way to go about these, but usually you want to try to eliminate and go from there. Okay, so that's how to solve a system of equations involving when you have 3 linear equations. So when you have 3 unknowns and 3 equations, that's how you would solve the system or solve for x, y, and z.